All right, so this little section we'll talk about not what to eat, but where to eat, and often in animal behavior, that where to eat we call those patches. Here is a food patch. This is where you get your food, and so the foraging decision on how long to stay in a patch of food. So you're getting food, it's coming to you, but as you eat, obviously the resources start to drop, and so then the question is, what do you do? Do you continue to stay in the patch because you know there's food there? It's just not a lot. Um, when do you make that decision to go to another patch? Now, the problem with that is there's travel time, like we mentioned from the last video. Um, as you're traveling from patch to patch, obviously you're not eating. So that becomes a problem. Okay, so there's a Shargoff, and he came up with this marginal value theorem on how you would make choices on food. And so his idea was a forager should stay in the patch until the marginal rare of food intake is equal to all the other patches. So as you're eating and it's getting lower and lower, you want to stay in that patch until it equals some of the other patches. The idea behind this is you have picked a patch that has a multitude of food. So you really want to stay there until it equals the patches right around you. Then the next thing is, depending on how close the patches are, will determine if you continue to feed there or do you move on. So you've equaled, or you're maybe even a little less than the patches around you. If the patches are close, maybe the decision is jump to the next patch. But if the patches are really far away, it's probably better to stay on the patch you're on because you know there's food there, even though the quality now is starting to drop. And then the idea is overall, if food is kind of scarce everywhere, you're better off, he suggests, staying in the poor patch instead of because of travel time and then heading into another poor patch. That doesn't make any sense to him. That you're losing time and energy, and so he did this actually with bees. Was his theory. So let's talk about another experiment on choosing patches. This was again done with great tits. Um, and they put them in this little, in a cage with this little apparatus. And so it's supposed to represent a tree. It's this metal tree with perches on it. And then you can see these little containers, and each of the containers will have some mealworms in it under sawdust. You can't see it, but the birds know it's in there. And then what they did to predict travel time, because obviously it doesn't take that long for them to jump from twig to twig, was to make it harder or easier to dislodge the lid to get that lid off. So some of them, the lid would just pop off real quickly, which meant they had a reduced travel time. And then if it took a while to pry that top off, then that would suggest a longer travel time. And so what they found from this, if you made the lids harder to get off, they would spend more time in each of the containers. They would stay on their patches a little bit longer because the travel time became a problem. So that's the idea behind that. Which patch if they are all equal? So this is another big question. Is what do you do if all the patches are equal? And how do you decide what to do? And this brings up this idea of risk sensitive foraging. So there are three different types of risk sensitive foraging. And the one on the bottom I should have probably put on top is risk insensitive. It means that every food item to you is about the same. And so for those animals, life is pretty much a straight line. Um, so you're not really making any major choices. You're just kind of eating until food runs out and then moving, I guess. Um, The other two, a little bit different, sometimes a little hard to understand. We have risk averse versus risk prone. So if you're risk adverse, you don't want to take a risk. And so the idea behind this is they did this experiment on robins, and what they would do is when they did the experiment, the robin was either had eaten and wasn't all that hungry versus a robin that might have been um, they might not have fed for a day or two. And so what happens is if you are full, you're risk adverse. That means your desire to find food is not high. And so what these guys tend to do is they pick patches that are pretty similar in food sizes. They don't want to see a lot of changes. You know, if I go here, I'm going to get 5 mealworms. That may not completely fill me up, but I know I'm going to get the 5. Life is not that bad, and I'll be okay. Rick's prone, on the other hand, these are a little bit different. They're going to gamble. They're hungry. They need food. So they don't want to go to something that's just 5, because although it'll feed them, it won't get them anywhere close to where they need to be. So what they'll do is they will gamble. You know, they might go to a patch which would have 0 or may have 10. Well, they're going to gamble. They're going to hope that it's the 10 one because they think the 5 is not going to be adequate. So it's kind of a different strategy depending on where you are, I guess, in the food cycle and how hungry you are. Do you take risks? You know, and I used to teach the class with Tim Ravel, and we kind of use this idea on how we golf. Now, neither one of us really golf. We hit the ball and then we chase it and lose it. This is how we golf pretty much. But when we first started teaching the class, we had gone golfing a few times together, and we have different strategies. And he considers me to be the risk prone, and he was kind of the risk adverse. So if you know anything about golf, there's a driver you come off, you know, off the tee. And it's the biggest club, and you can hit it the farthest, although there's the most ability for things to go terribly wrong. And so what would happen is I'd get up there with the driver, and I can get a great drive swing as hard as I could. And sometimes it was great. And sometimes I'd lose the ball. It just happened. And Tim, on the other hand, was risk adverse, me being risk prone. He was risk adverse, so he knew he couldn't hit his driver very well. So he'd always get like the 7-iron out, which, you know, the ball wouldn't go all that far. But he could predict it would go out, kind of land in the middle, and, you know, he'd pop it 100 and some odd yards. And so that's how we played the whole day. And it turned out, you know, we were fairly evenly matched toward the end of it. But we had different kind of strategies on how we got there. All right, and then we have yellow-eyed juncos are another concept that was done, and they're bird seed eaters. Although you notice the picture on the right, they will also eat insects. And again, they would vary the trays, and this was again trying to do that risk-prone and risk-adverse that we talked with the robins, and this kind of solidified. So these guys did exactly what I just said with the robins. Was basically it depended on how hungry they were, depending on how they acted. So it's not one species typically does one thing. It often has to do with the situation they're in. And so that will stop this one.